It is very exciting to be back at Elm Europe again. Last year was my first time at Elm Europe and also my first time going to an Elm conference. My first time speaking at an Elm conference, and I think something that struck me was how wonderful this community is, how wonderful the people who come to this conference are. And so I will say that I am very nervous to show you what I'm about to show you because it combines a lot of things I don't feel very confident in: art, live coding, and explaining audio processes. But I feel confident that at the very least people will be nice about any mistakes I might make. My name is Emma. My pronouns are they, them. And yeah, I was here last year talking about how my company at the time was using Elm in production and some of the things that we were doing to foster collaboration and learning. Since last year, a lot has changed for me. I've changed jobs and I no longer get to write Elm at work, but one of the nice things about that is that I write Elm for myself now, and I get to really guide how I want to build things and also what I want to build. So when I was thinking about what I wanted, or when I was thinking about what a proposal for Elm Europe might look like for this year, because I knew that the community here was so generous and kind, I thought I would push myself and experiment a little bit and do the scariest things possible. Make art, do some live coding, and try and explain audio processes. To explain why I, in particular, was interested in making art and making art with Elm, I have to tell you a bit of a personal anecdote about something that happened to me when I was a child. Those of you, I don't know if this is something that people do outside of the US, but when I was in 3rd grade, we were given an assignment to make macaroni art. And the objective, I think this is about what they were expecting. You know, it's fun, it's cute, but it's not the Mona Lisa. But when I got the assignment, I was very nervous because I thought that I had to produce something of the quality of a Mona Lisa type painting. And I remember sitting down with the blank piece of paper and my pile of macaroni and feeling so afraid about where I placed the first piece of macaroni, because what if I changed my mind and I didn't want that piece of macaroni to be there, but I glued it to the paper and there was no turning back. And I think over time, what I've realized is this fear of failure stays with us a long time, and especially when we're working in systems that do not give us the ability to fail forward and do not allow us to explore what life might be like if failure didn't have to always be fatal. Those of us who have programmed outside of Elm and maybe in languages like JavaScript have been burned by the times that error it can be equated to failure. There have been plenty of people who've already talked about the guarantees that Elm gives us that we might not find in other languages. But I think this also pertains to things like art. I think when we don't develop a sense of exploration, when we are afraid that wandering or exploration without purpose might lead us to nowhere, this can be very scary. And so this is why art is scary to me, but this is also why I wanted to try and make art with Elm, because I think there are guarantees in Elm that can help us explore and maybe move past this fear of failure. Prior to becoming a software engineer, I was a linguist, and so I often like to look at the etymology of words to understand concepts a little bit better. So as I was thinking more about error and failure, I wanted to see where these concepts were coming from and sort of what the etymological roots were. And I found some interesting things that I thought you also might like to learn. If we look at the root to err or error, in recent times, error has had a connotation to, or has become connoted with mistakes or transgressing in some way. But we look all the way back to the Proto-Indo-European root, you can see that actually to err was not necessarily about making mistakes even. It was about exploring. It was about being in motion. It was about wandering. It was about being in a part of flow. In contrast to that, failure has always been about something negative. It's always been about being unsuccessful, and also the consequences of what the lack of success might look like: ceasing to exist, lacking, dying. And what I found particularly interesting is if we go all the way back to Latin, there's a connotation that failure is not just an accidental lack of success or a mistake, but something that happens by way of something causing you to fall. And that's interesting to me because if we think about how error does not necessarily have to entail failure, in Elm, as Elm developers, we recognize that part of what gives us these guarantees is working in a system that does not cause us to fall when we err. Many people have talked about this throughout the past 2 days, but one of the things that really helps mitigate the fear of failure in Elm, of course, is the compiler. The compiler gives us these guarantees and this confidence that we can err, we can wander around, we can explore, but when we err, we do not necessarily paint ourselves into a corner from which we can never recover. We're not working with a sheet of paper, some glue, and some macaroni that is permanently affixed. Things can move around. Likewise, we also have, we're empowered in Elm to think about how we want to shape and model the world. Custom types, for example, give us a way to imagine how we want to create the ontology of an application. And I think this becomes a very powerful tool when we think about making art, especially for me, when I approach making art as someone who felt very insecure about it. I think Elm gives us the tools to prioritize imagination first before we think about implementation details. And because we don't have to be afraid of exploration causing us to fail or fall, we can start to play around with concepts that we may not be familiar with. I think about this a lot when I work with JavaScript developers, for example. At almost every job where I've written JavaScript, especially in a large code base, there's always a time in some kind of planning meeting when we're talking about building a feature or refactoring or considering technical debt, where the first response from some of the engineers in the room is to go to implementation details, to go to why we cannot technically consider something, even though we might want to build it. A user might want it. We might need to do it for the sake of maintainability. And yet the fear of failure at implementation is hindering our ability to imagine what more we could do. This has also come up for me recently in a book that I've been reading called Emergent Strategy, where the author, Adrienne Marie Brown, is sketching out a way to produce work, to engage in activism that allows us to release our idea of failure and instead embrace all of the data that is around us and to start small and then build bigger and better things together. And the thing that brings me back to art is this idea that in order to do all these things, we first have to imagine and we first have to dream of what possible realities are there. So that brings me to this small demo. What I wanted to do was, like I said, I don't know that I necessarily am an artist or good at art, but I wanted to see what could be done with Elm. And I knew I wanted to play with different media forms. So I knew I wanted to play with audio, and I also knew that I wanted to think about how I could visualize some of the data from that audio. At the time, I didn't know much about the Web Audio API, nor did I know all of the power that the Web Audio API provides. But I did a little bit of reading, and I was able to find some examples that allowed me to send data from the Web Audio API over a port to Elm. So this was my first exploration of just sending that data over and visualizing the individual points. And I will try and find my mouse. There it is. Okay, so all it's doing right now is it's visualizing individual discrete points. And what I wanted to play around with was being able to dynamically change the sampling rate of these points. So I think now we'll sample every 16th. And from here, I wasn't exactly sure what to do, but then I was like, well, points, as a person that enjoys data visualization, whenever I see points, I think of creating Voronoi diagrams. So this is what it looks like if you create a Voronoi diagram with all of the points inside of the frequency graph. And once we have the polygons, then we can start to think about maybe filling the polygons with some kind of color. Now, what data do we have to work with here? We have X, Y position. That gives us 2 out of the 3 things we might need for color, right? Okay. So I've made some kind of weird music visualizer, and that was pretty fun. And then I was looking at this and I was wondering where to go next. And what I realized was, well, if I have the frequency data, then I might be able to do some very basic processing from this. And what kind of processing could I do? So I wanted to see if it was possible to do some beats per minute detection using the Web Audio API. And once I found an algorithm that seemed to work fairly reliably, I thought, what should I trigger on each tick of a beat? My mind then went to animation, which I have worked with, but not in the capacity of syncing it with audio. And then, of course, I wanted to animate the Elm logo. Now, you'll notice that it's kind of jittery, and the reason why is that right now the animation is firing on every beat tick. Sorry, it's going to loop because it's a short song. And so what I thought of next was, well, if we think about how things in music go, not every beat is necessarily privileged in the same way, right? Up-tempo and down-tempo music privilege different beats. And so what might it look like if instead we fired the animation on the 1? And now there's a little bit more time for the whole thing to breathe and move and all of that. And yeah, that's kind of where I left off. I did not look at the Elm logo for the entire time. There are other things you can do with this, right? I'll show you in a second sort of how we're getting the data into Elm and how you might be able to extend this. But this was a fairly simple proof of concept for me in terms of being able to mix multimedia experiences and create something on the fly. So, where is my mouse? Okay. I hope I'm fairly certain they chose me to go after lunch just so I could play that very loud song and wake everybody up. Okay, so that was just a short example of how we can take one signal and then pass it to Elm and then reinterpret it in a different way in some kind of canvas. So how is it all put together? At a high level, like I mentioned, I'm using the Web Audio API in JavaScript, and then I'm sending some data over to Elm. The way that the Web Audio API works in JavaScript is that you have a series of nodes that you can connect up to an audio context, and then a special kind of node called a script processor node is able to emit data when the on-audio process callback is called. In addition to the script processor node, I've also attached an analyzer node. That's how we're getting the frequency data, and then a biquad filter, which is how I'm doing the beats per minute estimation. What I found interesting about working with the Web Audio API is that at this level of thinking about nodes connecting, it's actually quite similar in a lot of ways, of course, to how hardware or analog synthesizers work. This is Wendy Carlos in front of an old Moog synthesizer. So to break down a little bit some of the processes that are happening here, the beats per minute detection, that's happening on the JavaScript side. So I mentioned that I am attaching a filter node to the audio context, and the way that that's working is that it's a low-pass filter that is being used to isolate certain tempo-relevant frequencies. I'm assuming, at least in Western music, the lower frequencies tend to be the ones that correspond to the things that give us a beat or a rhythm, right? So a kick drum, for example. Once we can isolate those frequencies, then we can also identify certain peaks at that frequency level and then interpret those peaks as the hits of rhythm. And once we can do that, then we can count the intervals between the hits and then perform an aggregation over that to do the beats per minute detection estimation. I'm using a JavaScript library to do this right now, but something that I would like to explore next is doing this on the Elm side of things, because this is really mostly just like math and aggregation, and it would reduce, well, I'll show you in a second, one of the ports that I had to use to do this. On the Elm side of things, I have a port that is able to receive a list of integers from the callback that's being called on audio process on the JavaScript side, and I'm converting that list of integers into 2D points where the index position of each integer corresponds to the x-axis value, and then the y-axis value is the actual frequency value. Fun side note: when I originally was playing with this, I was doing sort of everything. I was trying to build everything from scratch, and I really wasn't writing the cleanest Elm code. I was just passing around tuples of ints everywhere. It got very confusing, and I thought I should probably represent this and model this in a better way. And as soon as I started representing the points as with an opaque type, I realized that I could also use Ian McKenzie's great Elm geometry library, so I'm using that to generate the Voronoi diagram. And then in terms of generating the animation, I have another port that is receiving the individual beat ticks from JavaScript. And on update, we are storing that beat count and then updating again with the message for firing the animation. We can also do so the second version that I showed, where I'm only firing the animation on the one, is happening by way of doing some simple modular math on the beat count, right? So if we assume like 8 beats per bar, then we can do some modular math to only fire off this animation on the one. So all of the technologies put together that came together to make this happen. Matt Griffith's Elm style animation package, which is how I did the animation. Ian McKenzie's Elm geometry, which I wish I had thought to use sooner, but came a little bit later in the process. And then on the JavaScript side, Joe Sullivan has an excellent blog post about how to write the beat detection algorithm using JavaScript and the Web Audio API. And then the JavaScript library that I'm using for the beats per minute detection is the real-time BPM analyzer. Like I mentioned, I think we can probably get rid of the need for the second port if we punt the computation of the beat detection over to Elm, and that's something I think would be a really fun next step. And then finally, in terms of the very aggressive electronic music you heard, this is a South Korean artist whose name is Kirara. If you like this kind of music, I highly recommend her work. So some thoughts about this process and some things that I've learned along the way. As I mentioned, I was very terrified to both try and create art, and I don't even know that we can call what I've produced here art, but I think it's a step towards feeling a little bit more comfortable in terms of pulling things together and expressing myself creatively. And it made me think about, again, what was it about Elm that made me at least want to try and step towards doing this? And especially when it came to the live coding part, I would say the compiler definitely helped. I knew that by the time the demo was done, I would be able to, create an API so that I could trigger some of the different effects that you saw without worrying about runtime errors, and that eased so much of my worry about having to produce anything that was interactive and dynamic on stage. The other thing is, I think, the community. I mentioned that one of the reasons that I wanted to try and push myself is that I wanted to, be vulnerable and try something new, because I've seen how supportive the community can be, and that's definitely something that even along the way in putting together this talk ended up being a huge influence. I'd like to return to this idea of imagination over implementation for a second, because I think, again, we've talked about this a lot already throughout these past few days. And I think as Elm developers, we're really privileged because we've really seen this put into practice. I think this is a really powerful idea because as I think about the world at large, I think this is something that we can definitely implement and also tell other people about. That, we don't need to, when there's something that we want to solve, or when there's something that we need to throw a little bit of imagination at, we don't need to first think about how we're going to do it or how hard it might be, but first to think about how necessary and important it is. And if the heat wave this week is any indication, we live in a world that is definitely in dire need of imagination to solve some of these problems we're facing today, and not starting from the fear of failure and implementation. The climate crisis is certainly one of them. I would say In certain places, we have issues with people who are unhoused. Where I come from, universal health care. In our industry, and in many industries, the questions of diversity and inclusion, mass incarceration, and also the displacement of people around the world. A lot of times when you bring up these topics with people, they will say, but how can we do it? It feels impossible. And that's almost seems to be the end of the conversation. And I think we know, as Elm developers, we know that it doesn't have to be this way, right? We know that we don't have to live in a world where not everyone doesn't have the opportunity to go astray, to be in motion, to wander, to err in the original sense of the word error. And that we don't have to live in a world where error can entail necessarily fatal failure. It's something that we have the privilege of being able to share with the rest of the world. And again, to go back to this idea that we must first start with dreams and then together we can collaboratively build towards it. I wanted to end with this quote from Ella Baker. This may only be a dream of mine, but I think we can make it real. That's it. Thank you.
Thank you very much.
Yeah, that's okay.
So, does anyone have a question for Emma?
Great presentation. In the demo, there was some stuttering sometimes in the animation. Do you know how that, or have you profiled that?
Yeah, so right now the biggest bottleneck in performance is the fact that I'm just sending like this huge array of ints over a port to Elm. In terms of like optimizing for that, I will say is very interesting because I have noticed that when my computer is in a very warm position, it glitches a little bit more, of course. But yeah, in terms of like how to improve that processing, I think there's a lot of stuff I could be doing on the JavaScript side in terms of like how I'm sending that over the wire. And the other thing that with the original SVG animation that I showed is I'm not doing any optimization for the animation, right? So I'm not using, and that would definitely be something that would help is if I am like re-rendering not like on every change, but rather queuing those animations up. And that's definitely something that I think would improve that performance issue. Yeah.
Emma, would sending a byte value?
Oh, yes.
Yes, would sending a byte value instead of an array of numbers speed that up?
Yes, yeah, absolutely. And then I recognize the nice timing of my talk after the previous one, because absolutely, I think sending bytes over the wire instead of integers would definitely help as well.
I had one other question on the frequency analysis. Is it sending over the Fourier transform of the sound?
Yeah, so it's what it's doing is it's just it's the analyzer node is doing a fast Fourier transform of the source file. Yep. All right, cool. Is there another or?
Any other questions? No? Okay, so I believe we have until 20 past for the next talk. So, somewhere.
Thanks, Al.